Firstly, thanks for that kind introduction and a big hello to everyone here. Today, in this talk, we are going to discuss how we can maintain and ensure performance like in React Native apps. So before we start, few things about me. As you already heard that that I I love to do open source contributions and maintain open source projects as well. And in that part, I'm right now one of the core contributor in React Native itself. Now let me set. Thanks. Okay. So now let me set the context for next few minutes. So we will be discussing around 4 key things. Firstly, we will see what performance really means. Then we will see why the tracking of performance in app is important and why it is often hard to track those problems very accurately. Here we will discuss around different problems, and then we will see how a tool called Marco that we built internally solves these specific problems. And lastly, we will see the impact of this tool in Dream 11 and in the community itself. So let's start by understanding what performance really means. So as you can see, so there are basically 2 ways to basically look into this. First is perceived performance, and the other is actual performance. Perceived performance basically means that making your apps feels fast without truly optimizing it. So as you can see on the slide, we have a nice loading app with a red color splash screen. But after that splash screen, there is a major white screen, and after that eventually the content actually loads. So this is a very common problem in the apps, or this white screen, which kind of hampers the actual UX. So one easy way we can think of solving this is just by extending the time of this splash screen to basically cover up this white screen. While this solution works and kind of solves the UX up to some extent, but if our app scales, this this solution can become a bottleneck in the future. So instead of just solving the problem by using some hack, we need to truly focus on actual performance. And for this, we need some numbers, we need some some detailed breakdown to see where the problem exactly is. Now let's talk about some common problems that many apps face. So usually when our app is simple, with less number of features, we really don't care about performance at that time. We just keep shipping features and things looks great at that time. But what happens when our app becomes complex, adding lots of complex features and making app more dynamic? So let's say each of these features is taking just 100 ms of time, and with just 10 such features, we can see a delay of around full 1 second on the app startup. And this will make our app starts slow, and user can observe this as well. We usually come to know about these performance regression either through Play Store app reviews, and we all know that Play Store app reviews can be very subjective. It can be as simple as your app is working too slow. So there is nothing concrete information that we can extract out from those app reviews and pinpoint where the exact problem is. But as a developer, we need to address those issues as well. So, but since the problem is incremental, it's very hard to exactly backtrack the things. So we often do some blind fixes, and after that also we need to wait for around 30 days, because in app releases we truly need to wait to for our app to be adopted by the new users. So in short, we definitely need some tools that can track those small slowdowns before we actually ship our app to the users. The other way by which we can track those performance regression is by using some post-production observability tools. While those post-production observability tools are better to check the overall stability of the app, like crashes, let's see what these tools provide in the performance domain. Talking about app startup time, here we usually get TTID, that basically stands for time to initial display, and this basically tracks when the very first frame of your screen is visible to the users. And I just put some markers on the TTID versus when the actual content is visible to the user. So for Dream 11 context, let's say match card is the one which is important thing for us to be to make our app actually usable for the user. And you can see a clear difference that TTID is marked at 0.9 seconds and the actual content is drawn at 2.5 seconds. So there is a very big difference. So TTID is not going to be a go-to metric to see when the meaningful content is painted on the screen. Apart from these, we also get some low-level metrics like CPU usage and the RAM usage and also FPS of the screen. While these metrics are good to see what happens behind the scene very internally, but these metrics are not going to be useful to see when the app is really usable for the users. So we need some way to track when the actual meaningful content is painted on the screen. In order to solve this, we can take inspiration from the web platform. So as Harshit already mentioned that that there is a very standard tool in web platform called Google Lighthouse, which basically gives us a score based on the core web vitals like LCP, FID, and there are many more core metrics there. This truly helps us to decide when the web page is actually visible to the user. But if we look into the app domain, we don't have such standard tools. So we can take a step forward and define two new metrics for app. First is FMP, that stands for first meaningful paint. That signifies when the first meaningful content is painted on the screen. And second metric we can define called LMP. LMP basically stands for last meaningful paint. This signifies when the when all the main content is painted on the screen. But there is a problem. How do we actually measure these metrics in a in a fully React Native app? In order to see this, how can we measure? Let's see what React Native offers. So there is a very famous lifecycle hook called use effect, which we often use, and there is a question on that as well, just before this talk in the quiz. So let's see what use effect provides. So use effect will basically track when the component is actually mounted on the screen. But does mount really means that the content is painted on the screen? Well, the answer is no. To understand this better, let's see how React Native works under the hood. So in React Native, we have a JavaScript layer where we usually write our JSX code. That is basically how we write our views. React Native will basically take those JSX and create an optimized JSON structure. Now there is a lot of things going behind this optimized word, which I think we already know in the talk of React Fiber internals. So React Native will create an optimized JSON structure. Now it will create some commands so that to draw on the actual UI. Behind the scene, there is a whole lot of native layer, Android and iOS, which is responsible to actually draw this. Now use effect comes into picture at the commit phase. So it is one of the last point in the JavaScript layer when React Native just will call this this lifecycle methods and then just send this command to the native layer through some bridge, maybe JSI or the old bridge, based on which architecture we are, and then actual native layer will be responsible to draw this on the UI. So if we put performance marker in the at the use effect, it will be too early, because there is lot of work going on the on the native side. So we definitely need some signal from the Android or the iOS world, so that we can say that whatever screen we are going to paint, it is actually visible to the users. Also, those performance data should be like consistent enough. Like it should be same across multiple iteration, and there should be some way to actually to like properly visualize those data as well. So in short, we need some tool which help us to track the things. It should provide a very consistent data and should provide a dashboard or a simple panel so that they can see or we can like compare multiple reports or we can like see trends. But wait, like what's the actual real cost of all these problems? It's huge. It's gonna impact our user experience and thus our business. Now to truly understand what the importance of like 100 ms in an app development, let me share an insight from Dream 11. So last year during IPL times, we had reached a massive scale of like 15 million concurrency. That means 15 million users are trying to access our app like within a 1 minute window. And if we do simple some maths and try to calculate the actual number of users in that small window, this 100 second, this 100 millisecond, it is going to be a 25k users. So 25k users are trying to access our Dream 11 app in this 100 millisecond. And if we take our like one of our important string, that is contest, which helps the user to actually join any contest. And if let's say somehow this contest screen gets delayed by that time, those 25,000 users will not be able to join the contest, and that will like create a big impact. And if you just try to extrapolate this 100 millisecond to a full 1 second, the impact will be massive. So in app development, we should care about these small slowdowns as well, so that it shouldn't become a bottleneck in the future. In order to solve this, let me introduce Marco. Marco basically help us to track the so Marco is basically a very lightweight performance tracking library specifically built for RN apps. It seamlessly works across Android and iOS, and it supports both the old and the new arc as well. Now let me share the history and the thought process behind building this tool. So this tool was created like 4 years back, when we have our biggest project in the front end domain of migrating 250 odd screens to an entire new framework. So our old screens are written in Android and iOS, like in Java, Kotlin, or maybe in Objective-C and Swift. And now we need to migrate each of those screens into a RN. One of our major challenge at that time is we need to ensure that whatever the performance behavior we have initially, we want to keep that up or maybe improve that after migration. And to ensure this, we created this tool Marco, which help us to basically benchmark all native screens and RN on the same page. So basically, so we should have a apple to apple comparison, because React Native is written in JS language and Android is indifferent. So at that time, Marco helps us a lot to ship that project very efficiently. Let's now see what are the Marco capabilities. So starting from the very first, so it basically provides a set of tools which helps us to manage the app performance end to end, starting from the very first, that is tracking. Marco provides a way to track those metrics like LMP and FMP of any screen or maybe app startup. Apart from this, it also provides APIs that helps us to track the performance regression in the Android and the iOS world. So we can connect React Native with the Android and iOS together and can see a complete picture of any specific trace. So for example, if we need to track app startup time, then we usually know that app startup usually contains consists of code from React Native and the Android world or the iOS world as well. So we can use Marco here to see where the exact problem is, and we need to then just focus on that specific domain on. It also provides API. So if you have like some brownfield app in which you have some screens in React Native and some in Android or iOS written, you can use Marco there as well. It provides API to like benchmark old native screens and RN both. Second is basically generate. So Marco also provides you a way to generate consistent data and provide some basic statistics like mean, standard deviation, and error rate that helps you to decide whether your data is correct or not. And it also works out of the box with multiple instrumentation tools like Maestro and Detox and many more. Third is basically visualization. So it provides you a set of CLI commands. With the help of those, you can better visualize those reports. And the best part is all these tools are very easy to automate. Let's now see Marco's core, like how Marco exactly track those LMP and FMP. So for this, let's take a sample code. Let's take a sample screen which have a state loading variable called isLoading. On the basis of that, we are either showing a screen loading text or a screen loaded text. And let's say for now we want to track exactly when screen loaded text is actually visible to the to the users, and let's call this as a FMP of this screen. And we know that putting the performance marker on the use effect is not going to be helpful. So we need to go like a one level deeper on the Android side to see like how screen loaded text is actually visible. So React Native will firstly create some command, as you all know, with some important informations like type of view, styles, and ID. This will like then send these commands to the Android world. So now Android basically like take those commands and tries to convert your views in its primitive. So view is converted into a view group, and text is converted into a text view in the Android. Similarly for iOS, we have like those native primitive for iOS as well. Now your Android world will have those primitives, which then undergoes a series of lifecycle methods. Starting from the very first, that is on measure. Here the system will calculate the dimensions of those views, like width and height. After that, it goes to on layout, where the system will calculate the exact pixel by pixel calculation, at where exactly this screen loaded text is to be seen on the screen or painted on the screen. And then after that, at the very last, your on draw hook will be called, which have all the sufficient information about like pixels and about the width and the height, as I already said. Now this on draw hook will create some GPU commands, which then needs to be sent to a separate thread to actually draw your UI. So because of this GPU command which on draw creates, our screen loaded text is finally visible to the users, which is done by a separate thread. As you can see in the complete picture, on draw is one of the last point where we get that information that our component or the view is now going to be painted on the screen. So Marco basically uses this on draw hook to precisely track when the screen is painted or not. But to keep it simple, it just provides a simple HOC component called performance tracker. So you just need to wrap your screen with this and it will do the things inside. Let's see Marco, like what Marco offers as a report. So to visualize an individual report, on the left you can see like multiple events which are fired from the app, like app launch start, when the application on create is ended, when the activity is created. You can see all those events on the left side, and then on the right we have a detailed stack graph, which helps you to decide like between which two consecutive event it takes more time. And just below this we have all the like basic statistics like mean, standard deviation, and error rate. And apart from this, it also helps you to compare like multiple reports and see the trends across like multiple versions. All right. So till now we had seen like what performance really means, and like what are the common problems that many apps face and how Marco solves this. Let's see how we are like how in Dream 11 we are using Marco. So right now we have a fully automated performance pipeline which kind of tracks like various major metrics, starting from the very important and the very first app startup time. So we run a job like daily on a like 3-hour basis to track this important metric. After this, we had also like identified 15 to 17 important screens, and we track FMP of those major screens as well. Apart from this, on those important screens, we had also identified 2-3 critical interactions. So Marco is also like being used to track those interactions as well. And to power all this, we had written around 50 plus like performance tests as well, which kind of, and if you see in the last 2 years, we had around 5,000 plus performance job runs only, which kind of powers 300 plus app releases across 3 major platforms. So it's iOS app, Play Store APK, and the web APK. So this basically helps us to make sure that like if we have any performance hit, we can take better better decision before shipping the app to the users. And apart from tracking those core metrics, it also helps us to take some big decisions. So let's say in your app you're trying to integrate or maybe upgrade any of your core library. Then it also helps us to see whether there is any performance degradation in those libraries or not, and we can like take decisions accordingly. It also helps us to like drive like new experiments very efficiently. Now, last year in React India, we had introduced this React Native benchmarking tool. This helps us to basically see the performance behavior of React Native across like multiple versions. And here we basically benchmark the RN primitive components like view, text, and image. At that time, like this tool also uses Marco at its core, but at that time Marco is internal. Now after making Marco as an open source package, we took a step forward and did a thorough benchmarking for almost like we had started doing benchmarking for all the core React Native libraries as well, starting from like React Navigation, React Native bottom tabs, and Goram bottom sheet. And because of all this, you can like find a central place to see all those benchmarks and like take your decisions as well. And this also helps you to decide like what's the exact baseline numbers these core libraries provide. So let's say if you are integrating like React native bottom tabs in your app, then you can see that like a bare minimum like native bottom tags takes around 300 ms to load. So based on that, you can decide whether you want to go like with a JS stack implementation or the other one. Okay, so to know more about like Marco, just check out the marco.dreamsportslab.com. We have like complete documentation there. And on the right side, to know more about like the core benchmarking libraries, check out this React Native benchmarking.dev or like scan this QR code. Thank you.